So this is how the wave characteristics that we will see. The amplitude, that is also called as a crest, then trough. Yeah, so that is the maximum displacement of the particle from its just nothing but the mean position. So this is the maximum amplitude. Then this is the trough. The distance between or the one crest and one trough consists of your wavelength. Yeah, so that is what we can say about the wavelength also. So let's say for example, so the same thing, the distance between the two nearest point in which waves are in the same phase is called nothing but the wavelength. Yeah, so these 2 points, so this one and this one, so this is point 1, this is point 2, they are in the same phase, so that's why we are going to call them, so this distance we are going to call it as a wavelength also, or this one over here, so that is what we have shown as a wavelength. Again, the time taken to complete one vibration is called as nothing but your time period. Again, frequency is nothing but the number of your vibrations completed in 1 second. It's called the frequency. So again, the velocity of wave. So the velocity of wave, so the distance traveled by wave in 1 second is called the velocity of wave. So obviously where I'm just going to transmit those vibrations towards the next particle. So this velocity you can write it down in terms of frequency and wavelength. So that is V is equals to F into lambda over here. Yeah, so this is how we can say over here. So this string particle which sets into vibration over here, and definitely you can say that. So here there are two things, there is a velocity of particle and velocity of wave, both are different things. So obviously how fast the disturbance is transferred from one particle towards the next particle, so that is what we call as a wave velocity, and the particle velocity where the particle is just going to vibrate about its mean position. So both the things are different. Yeah, so just don't get confused between those two things. So the particle velocity, the velocity of particle executing SHM is called the particle velocity. So this velocity we just write it down it as a dy by dt, or we can just find the expression for that also. So we have seen that in SHM also, the velocity of particle where v is equals to omega square root of a square minus x square. So instead of this x, even we can consider it as a y. Along this y direction it's vibrating, so v is equals to omega square root of a square minus y square. So this is the velocity of particle, so with which it is going to do those vibrations, so that is we will call it as a particle velocity. Also in this case you can find the maximum velocity also. So if you remember that, so obviously this maximum velocity where it occurs at the mean position. So when obviously you can say that your amplitude becomes 0, so we can say that v is equals to your omega y. So that is your mean, that is nothing but the maximum velocity, so which is nothing but plus or minus omega y. You can just write it down, or in terms of magnitude, so that is how we can write it down over here.